Hello, class. This is my first attempt of trying to do remote learning while here at home. I'm going to basically try to walk you through a little bit of this PowerPoint that explains a little bit of magnetism when you have it caused by electricity. This is called electromagnetism. And again, the whole concept is if you have a wire and if you have electricity traveling through it, it actually becomes a little bit magnetic, this wire, even though this wire is made out of probably copper, which is not ferromagnetic. But if you have electricity going through you, then you will become magnetic while that current does travel. So this is kind of the concept. And yesterday we left off, we had this little PowerPoint slide here, just kind of giving you the introduction, if you will. But what I want to go over and kind of intro today, again, today is Wednesday. Your spring break is in basically 2 days. I don't want to overdo this and throw a lot at you, but just to give you a little bit of familiarity and also to help you pass the time because I bet a lot of you are already pretty bored. So, again, hopefully, this is somewhat entertaining every day. So, again, this PowerPoint we have in front, we kind of looked at yesterday. Apparently, electricity traveling through a wire. And yes, this is just a USB wire, but best example I have at home. Best you have electricity going through a wire, and it's going to create a magnetic field. Now, the next slide I have here is kind of asking about the direction because right there, if you look, okay, traditional bar magnet, we've gone over that the domains on the inside are pointing from the south to the north. And then outside, it's kind of called the external magnetic field. It would be exiting the north and going into the south. But basically, that's a traditional bar magnet, easy to memorize, no big deal. What I haven't showed you is what if you actually have like a wire? Like we know that the current is going to travel from one end to the other, but what is the direction of magnetic field? Like where's your north? Where's your south? So to actually help with this, there's a very nice, simple, straightforward rule, which I have on this next slide here. It's called the right hand rule. And it's the first one because there's a few different situations this can be applied. The first is to simply straight piece of wire, just like this, nothing special. And the reason why it's called right hand rule, you need to be using your right hand. Now, this is where it's awkward because I'm doing a video and this, you are going to see it on your left, but this is my right hand. I actually do have the option. I could flip this, but then I don't know, is this actually, I guess this might be better for you because this is my right hand and you're going to perceive it from your right side. This is weird. Learning, again, we'll get used to it. Little side bit, you guys might think it's kind of silly that there is a rule that's using your right hand, but I want you guys to take a moment and be very grateful that all of you guys have two hands because when I was in college, I remember in the dorms first year, there's a guy, Eddie Gonzalez. If he ever finds this YouTube video, who knows? Shout out to Eddie. And I remember met him, and then something caught my eye, and I couldn't quite make it out for at least a few days. I was trying not to like put too much attention to it, but eventually I noticed that he was born without a hand, and I believe it was his. I think it was his right hand. I could be wrong. Sorry, Eddie, if I got it wrong. But he basically, when he was in the womb, umbilical cord wrapped around his hand, and he was born without a hand. And his entire life has been like that. But he made it pretty well. And you might be surprised, he was a computer science major. So you know what? People can adapt even when they don't have the benefits that a lot of us we do have. So be grateful, even though you're locked inside. At least you have, hey, it could be worse. So anyway, right hand rule number one. It's applying to a straight piece of wire. And if you recall from yesterday's YouTube video, it's a pretty weak magnetic field. It's not going to be that strong, but there still is a direction to it. And for this, you're going to use this is my right hand, because see, wedding ring is on my left hand. So for your right hand, what you want to do is basically your thumb, make a right hand thumbs up gesture. Hey, thumbs up, we're all happy. And your thumb is going to point the direction that the current is traveling. What I'm going to do, I'm going to use a pen as kind of my little example of what the wire is or would be. And it's kind of easier if I literally just grab that pen and I go, okay, apparently if the current is traveling upwards, there's a magnetic field and it's kind of going in a weird circular pattern, like always, always, always around like this. And if the current was traveling sideways, that magnetic field is going around like this, or this direction around like that. Again, if you haven't noticed, it's pretty awkward to do this with video or even just to kind of show people and to illustrate this. I mean, I want you to take a look at the PowerPoint for a moment. Let's say if I had to draw this on the board and go, by the way, if we know that hand is pointing upwards, magnetic field must be curling. By the way, I guess I forgot to elaborate. It's the direction that your fingers naturally curl. That is the direction of magnetic field. But notice, if I was going to try to draw that on the PowerPoint, considering my artistic abilities, it is pretty sloppy. So they actually developed a system, and this is what's written down here in the corner: into the page, out of the page. And what this is talking about, you may have noticed in real life that we live in 3 dimensions. Again, there's up, there's sideways, and there's also in and out. That is the whole concept of X's and O's right there. And to help inspire a little bit, I always play this every year. And even though we're not in class, I just cannot help myself. Okay, I'll stop there. Anyway, just for good kicks. But basically, X's and O's are a nice way to illustrate, especially on paper, hey, what is the direction of the magnetic field? So looking at this illustration here of that hand, we know that it is going to curl around in this direction that the fingers would be curling. But what you can do is, if you want to illustrate it on paper, you would say, all right, it looks like these fingers are coming out of the page. I'm trying to make this match the camera. They're coming out of the page. And so out of the page, you would basically just draw an O. These are meant to be O's on a quiz. And then this side of the wire, you'll notice the fingers are kind of going into. And going into, you would basically just draw X's. X and an X. And whenever you're taking a quiz for this, you can literally, it's funny, you are often just kind of sitting there and doing sort of gestures with your right hand and must be with your right hand. And again, I often find holding a pen or a pencil is a good way to kind of just help visualize that a lot better. For that top slide right there, again, right hand, thumb is going the direction that the electricity, the current is going. Your 4 fingers are naturally curling in the direction of that magnetic field. And you'll notice that, hey, these fingers are currently going out of the page. I guess you have to kind of do out of the page. And on this side, they're going into the page. And that's why you have your X's and your O's. And this can be illustrated down here as well. It looks like on top here, they're coming O out of the page. And down here, X's, those are meant to be X's, into the page. So basically, I'm going to give a worksheet probably tomorrow, a little bit kind of like practice with this, because especially since we don't have paper things to give you, this is all going to be a fun, interesting experience. But at least a little bit of intro today. And you know what? Just make sure that you're leaving on a good note, you know. Okay. Anyway, guys, intro lesson, take it easy out there. And again, every day I'll probably post a little something just to help you learn a little bit more about our lessons and just to help you pass the time. I hope you're all doing well. If you have any questions, feel free to email me, okay? All right, bye.